we discuss about thermodynamic process. What is actually a process? Process is of course just nothing but a path followed for a change. Path followed for a change is what we call process. In what process? What is the path? Like we move from one place to the other place, or if we want to go from one place to another place, then what is the path that we follow? That is process. Or what is the mode of operandi? That is also process. Like whether we go by bus, or we go by train, or we go by walk, or we go by flight, that is also come under process. Or what is the path that we follow? That is also process. So, anything whatever the mode of operandi is there for a system to change from one state to the another state. A path followed for a change, that is when a system moves the direction of system to move from one state to another state. Right? Here this can be a direction or mode of transfer, that can also be process. Here these processes have been classified into different types. One classification is, type 1 classification is reversible and irreversible processes. What is reversible and irreversible process? Irreversible process, let us first example if we look at it. Irreversible process is the one which takes place in one single step, or a sudden change. A sudden change is what we call irreversible. Any sudden, a process in which sudden change takes place, a sudden change takes place is irreversible. And also the other way is that during the process system cannot be stopped or cannot be brought back to initial state. A process in which system cannot be stopped from change, cannot be stopped from change. If once the process starts, we can't stop it from the change, or in other words we cannot bring back the system to the same initial state. Those type of process are what we call irreversible process. Graphically we represent it. Suppose if a gas is expanded, then a gas initially at a P1 V1 state to another state B, the sudden jump, sudden expansion or sudden contraction, sudden change in state with a single, it starts here and directly reaches here without any intermediate stage, is what is called irreversible process. The best examples here is that jumping down from the top of a hill is irreversible process. From the higher floors, that is irreversible process. Rolling down a stone from the top of a hill, rolling down a stone from the top of a hill is irreversible process. If once it starts, again the stone cannot come back, and it cannot be stopped in between, means it cannot stay at if once it starts rolling down, it will stop again at bottom of the the bottom of the hill, but not anywhere in between the passage, in between the path. That is what is called irreversible process. Sudden cooling, sudden heating, sudden expansion, expansion of a gas into vacuum, expansion of gas into vacuum where pressure is 0, vacuum means pressure is 0, expansion of a gas, that means moving a gas from high pressure to 0 pressure, that is what we call expansion. Expansion into vacuum is irreversible process. If once gas starts expansion into vacuum, it cannot be stopped, it cannot be reverted back. All these are what we call irreversible processes. And here more technically, this irreversible process what is said to be, if the force that is acting for the system to move in the forward direction or in one particular direction, if you call it as the driving force, and the force that act to bring the system to bring back to the same initial state, if you call it as a opposing force, then if driving force is greater than opposing force, that means system only will be keep moving in the forward direction, but it cannot be reverted back, because driving force is much higher than the opposing force. The opposing force cannot be, the opposing force is not acting on it, it is only the forward force, that is the driving force is only acting on it. So, as the driving force only is acting and no opposing force is acting on it, system cannot be reverted back. So, technically what we will say is that an irreversible process in which there is a large gap difference between the driving force and opposing force. So, the system cannot be brought back to the same initial state. This kind of processes are what we call irreversible processes. Then what is reversible process? Let us see in detail. Reversible process. A reversible process is the one which takes place with infinitesimally slowly. A process, irreversible process is which takes place suddenly. Reversible process is which takes place infinitesimally slowly. It appears as if that the process is not moving at all. The process moves in such a way that it appears as if that it is not moving at all, that is infinitesimally slowly, or with a small change, and it takes place in infinite number of intermediate steps. Infinite number of intermediate steps, that is reversible process. And system can be brought back, system can be brought back to the same initial state, system can be brought back to the same initial state at any stage during the process. That means, system can be stopped at any stage. It is, now we can easily differentiate that reversible and irreversible. Going by staircase to higher floors, using the staircase, going by staircase to higher floors, say from ground floor to 5th floor, one has to go, then going by staircase is reversible process, as it involves large number of steps, many number of steps, one step by one step, unless you move step by step, you cannot reach. And during that process, after reaching say second floor or third floor or from anywhere in between, if you want to come back to ground floor, we can come back. We can come back to the ground floor. So, at any stage the process can be reverted, at any stage we can stop, and otherwise we can be keep moving step by step infinitesimally slowly. But the same climbing, the same process, the same target, if you do it say by another operation, that is, if you use a lift. If you use a lift, if once you get into the lift, and if once you press the button 5, and if once the lift starts moving, then in between we cannot stop it. In between we during the process we cannot come back, unless the lift reaches to 5th floor, again we cannot come back in between, that is irreversible process, and it takes very less time to reach 5th floor as it moves. So, it is all a single step process, directly from ground floor to 5th floor, it is a single step process, but moving by staircase is a reversible process. Graphically, as already we have shown, that if the change is a sudden change, this is irreversible, and if the same change is brought by infinite number of steps, same change is brought, but by reversible change. This is reversible. So, this is the difference between reversible and irreversible process. And here, so it is, suppose if the system starts at A, it undergoes many intermediate changes to B1, this is A to B1, B1 to B2, B2 to B3, B3 to B4, B4 to B5, and finally it reaches B. So, there are so many intermediate steps that are involved, and the system can brought back to the same initial state during any stage of the process. And here the difference between opposing driving force and opposing force, driving force and opposing force are nearly same. So, the system can move in any direction, either in the forward direction or in the backward direction. It will be keep moving in both the directions. So, it goes infinitesimally slowly, and change is very small change, and infinite number of intermediate steps, as you can see it over here. So, this kind of change is what is called reversible change. And very important point is that work done in reversible change is always greater than work done in irreversible change. This is very important. Thermodynamical point of view, what we require here is that in the thermodynamical point of view, why we are discussing this reversible and irreversible process is that in the work done in reversible process, as you can see, even in general, in climbing to 5th floor by staircase requires more energy than going by lift. Going by lift does not require any energy that we have to consume, but we have to consume a lot of energy and we have to do a lot of work to go up to the 5th floor by staircase. Exactly the same thing, as to move up, more energy is to be done, more energy, more work is to be performed, rather than, or even coming down from A to B, even to come down by staircase we have to do certain work, but to jump from A to B it is not required to do any work. So, the point what we have to understand is that work done in a reversible process always greater than work done in irreversible process for same change, from same state A to the same state B. If you do irreversible and if you do reversible, the work done here is more. This is what is the main difference between reversible and irreversible processes. Next we will see the other type of classification. Isothermal process. A thermodynamical process is said to be isothermal process if the process is carried out at constant temperature. Process carried out at constant temperature is what is called isothermal process. Isothermal means same temperature, that is at constant temperature, that means delta T is equal to 0. And whenever a process is carried out at constant temperature, the change in internal energy of the system is also delta E or delta U also 0. What is internal energy, that we discuss next, but of course, in brief here to tell, internal energy is nothing but sum of kinetic and potential energies, sum of kinetic and potential energies of a system. That kinetic energy includes all types of kinetic energy, rotational, vibrational, translational, nuclear, all types of energies. And as we know very well that kinetic energy is dependent on temperature and kinetic energy is proportional to, as kinetic energy is proportional to T, if delta T is equal to 0 implies delta E or delta U is also 0. That is the reason when change in temperature is 0, that means as long as there is no change in temperature, also there is no change in kinetic energy. As there is no change in kinetic energy, also there is no change in the internal energy of the system, that is isothermal process. The next another process what we have is adiabatic process. What is adiabatic process? Adiabatic process is process that is carried out at constant heat. Here this is constant temperature, means delta Q is equal to 0. Delta Q is equal to 0. Change in heat content is 0. As a change in heat content is 0, here the, of course, in the first law of thermodynamics we say if any work is performed in an adiabatic process, because here the heat change is 0, that work is performed only at the cost of internal energy, at the expense of internal energy. So, one point, of course, later we discuss them in detail, work done in isothermal process is always greater than work done in what you call adiabatic process. Then another process next what we have is the isobaric process. Isobaric process is the one where the process is carried out at constant pressure. At constant pressure, when a any change is brought when a gas is, suppose here if you speak in terms of the expansion of a gas, if a gas is allowed to expand in isothermal process, then as only the internal energy change from the first law of thermodynamics, that all the heat change is converted into work. Here heat is constant, so work is done only at the expense of internal energy. Here neither the heat is constant nor the temperature is constant, the constant is pressure over here. So, here more work is done, and so here the whatever the heat that is given, all that heat is converted, some part of heat is converted to change in internal energy and some part to the work. So, here the total change will bring, all the changes will be made and work done is highest. Here work done is highest. And isochoric process. Isochoric process is the one which is carried out at constant volume, and normally work done is given as minus P delta V, and here delta V is equal to 0. Therefore, in isochoric process work done is 0. So, like this, if you compare overall work done in isobaric, work done in isobaric greater than work done in isothermal greater than work done in adiabatic greater than work done in isochoric. Work done in isochoric is 0. This is equal to 0. This is, well, this again after first law of thermodynamics we will understand it more clearly. Graphically also we will represent it. This is with respect to pressure volume work is what we are talking, and what is a work, how do we define work, what happens, what is internal energy, more clearly we explain. Now, here we are giving all this in brief, just only to explain the differences of isothermal process, adiabatic process, isobaric process and isochoric process, right. So, these are the other set of classification, and just one more type of process that what we have is cyclic process. What is cyclic process? We will see now. Cyclic process. Cyclic process is a process in which the system is subjected to a series of changes, but finally it is brought back to same initial state. A process in which the system is subjected to series of changes, many changes have been made, but after a series of changes it is brought back to same initial state. It is like in the morning we start at home, we go to work, and as a part of our work we may go here and there, and even while coming we may go to some shopping, and from there we may go to some friend's house, but finally by the night we will come back to our home. So, after a series of operations, after so many visits in between, finally we are reaching home. So, it is something like this. A gas is allowed to expand by different process, pressure, volume. Suppose it starts over here, change it to B, B is changed to C, C change it to D, A. Initially it started with V1 P1, then B, then C, then D. This is a cyclic process, A to B, B to C, C to D, D to A. This is a cyclic process. And the cyclic process not only like this, even it can be 3 step, A to B, B to C and C to A. Even it can be a 3 step, or even it can be like this, so many changes, A, B, C, D, E, F. In all the process it is the same, from same initial state, from one single state it is finally reaching to the same initial state after different paths. And the area under the curve, area of the curve, this area of the curve is equal to work done, PV work. This again in the first law of thermodynamics more clearly we say why it is equal to work done, what is exactly this PV work, but whatever it is. So, here this is again as simple as this. Here you are taking 4-step process, here you are taking a 3-step process, here you are taking a 6-step process. For the same change, obviously here as you can see the area will be more. Obviously when you are taking 6 steps, that means starting from home, visiting so many areas and finally coming back, obviously that requires more work. So, it is as simple as that to understand, and all these are said to be cyclic processes. In a cyclic process, the final heat change, net heat change or net internal energy change, all these are 0. In a cyclic process, as we told, if you start from the home and if you visit so many places and finally when you reach to the home, the distance travel of course increases with increase in number of steps, with increase in number of visits, but net displacement is 0. Finally when you are reaching home, you are starting from here, you have travelled this distance, the distance is increasing from here to here, here the distance what you travelled is more, but the net displacement finally here is 0, here is 0, here is 0. Net displacement is 0, but distance travelled is more, work done is more. The work done which is based on the displacement, work done is more. Work done changes with change in the path, but displacement, that is nothing but heat change or internal energy change, that will be 0. Finally, the system is brought back to the same initial state, to the same initial heat content it will acquire, same internal energy the system will acquire. So, net internal energy change is 0, net heat content is 0, but work done will change from one path to the other path. This is what is called cyclic process.